Hello, everybody, and welcome to another exciting, fun-filled, expeditious episode of Radiorama, where, as the name implies, I show you how to work on primarily radios. And today we have a 1956 Traveler model 46-37. And Traveler was, I believe, based out of Long Island City, New York. It's kind of like the industrial manufacturing hub of New York City area. It is a very basic radio. It has only 4 tubes. It is a super heterodyne. Performance is going to be limited to local broadcast, which is fine if you live in a city, not so fine if you live out in the sticks. I do not know if it works or not, so we're going to go ahead and turn it on. Let's see if I see any. Yep, alright, tubes are glowing, so at least it's got filament. Again, it's probably not going to pick up much, if it works at all. Okay, that's all I needed to know. The filter caps, which are the electrolytic capacitors, are shut. So either it's firing on the original capacitors, or someone's replaced them and that was a long time ago. But either way, it's not going to work with those capacitors. Again, it's a basic model. No, there was never a plastic lens here. The indicator and the dial underneath are completely exposed. Dead giveaway for era. I did look up the model year, which I hardly ever do, but the civil defense markings usually indicate it's at least 1955. And I believe they got rid of the civil defense markings in 1963 because at that point it didn't matter, because if you had an intercontinental ballistic missile coming your way, there was no time to really do anything about it. Scary times. So what I'm going to do is take the chassis out. There's probably not much to do that. There's 2 screws and these 2 little pull-out thingies that hold the back on. It's got a good solid back on it. And I know Traveler, again, they made really cheap things, so I'm hoping it's not a hot chassis, because if it is, I'm going to have to think about it for a little bit. Okay, so here is the now exposed chassis, and I can see they tried to compensate for the lack of the 5th tube. They've got this rather large ferrite rod antenna, and then there's a 2-gang tuning condenser. I wonder if the chassis in this was initially made for octal tubes, because we've got these large holes cut out with these oversized phenolic sockets for the miniature tubes. And looking underneath, it appears, just from my looking at the condition of the solder, I think it's actually original. I don't think it's ever been worked on. So that's the original electrolytic capacitor. And there are 3 values inside. I'll have to kind of twist this around to see what they are. I can take a good guess. Let's see. 40, 20, and 10. And the third one, which is 10 microfarads, is only rated at 25 volts. The rest are 150. I'm just going to replace the first 2 with 47 microfarad 160 volt rated caps, and I'll find a low voltage 10 microfarad for that guy. It is luckily not a hot chassis. If it was, I'd be looking for this, which is, you see, this is one end of the line coming into the on-off switch. And instead, it's going through this gargantuan capacitor to chassis ground. And that's probably way too big of a value. It's not as dangerous as being a true hot chassis where everything coming out of the cord goes through you. Instead, it's being limited by this capacitor. But it's probably enough to really give you a jolt. Probably not enough to kill you, but make you very, very uncomfortable. So we're going to replace that with the correct capacitor, which will also be a different type of capacitor. It's going to be a X2, Y2 across the line safety capacitor. And other than that, there's only 2 more paper caps in it. It's such a basic thing. Sometimes these sets that are so basic and simple are kind of refreshing. And it looks like the chassis is made out of galvanized stamped steel, hence there's no worry about the other type of material that they use to plate these guys a lot, which is usually cadmium. I'm looking, and all of the tubes have Traveler written on them. Traveler did not make their own tubes. They contracted someone to make those tubes for them and put their names on it. And the fact that they're all in here with the original names, sometimes when I see that, I wonder, well, how much use did the set have? Because if you use the set excessively, it would be expected at least either the output tube or the rectifier would go out, because those tubes get hot. They take a beating. So first things first, let's get out our supplies and get to town, go to work. Okay, the first thing that we're going to do here is remove this old electrolytic and cut all the wires going to it. Let's see. Of course, trying to do this one-handed while filming, that's real great. Really need to get a better camera. All right. So now that's out of there, we have all of our different connections here. Where'd the yellow one go? Here it is. Where does the yellow go? Okay, so it looks like red and then yellow attaches there, and then blue goes way over here, and the common negative that they all connect to is right there, and that's a really tight spot. So this is usually when you need to think about, where can I mount the new ones? And here's the new ones, and you can see how tiny they are compared to the big old jumbo one that it's going to replace. And I think what would be an easier method of dealing with this would be maybe mount the 10 microfarad one here on the common negative, and the rest of them I'll just run a jumper negative to both of these other locations, because this guy's so far away. I don't want to have to run a super long negative wire to it. This is the safety cap. They tend to be blue, not always, but a lot of the times. And then one of the other values is a .047 rated cap. You can see it on the side here. I can't tell what the other one is, but once I get to it, I can twist it around and see what the value is. Most times I don't even bother looking up the schematic, because they're so basic. All I need to do is just look at the values on the capacitors. And when it comes to electrolytics, the rule of thumb is replace at or greater the value of the capacitor, and it needs to be at or greater the voltage. It doesn't hurt to err a little bit on the side of more. That's why a lot of these capacitors, even though they're rated for like 600 volts or something like that, the most you'll ever see maybe at flash turn on is maybe a couple hundred. The one that is really important is the across the line one, or the grounding cap in some cases, because that gets hit first. And so there's a potential for a static charge to be in excess of 1,000 volts, even though in the US we run on 120 volts. If you're in the UK or if you're in Europe, I'd expect it to be even greater, because sometimes I'll get sets in that are from Europe, and their across the line caps are already, 1940s and 50s, they're rated at over 1,000 volts. So I would expect standards have changed for that as well. I wouldn't be surprised if you should probably put a 2,000 volt cap in your across the line cap. So let's get started. I'm going to go ahead and mount the electrolytics, and then we're going to give the set a test to see if we have returned operation, and then we'll proceed with the rest of the capacitor replacement. Okay, I kind of fibbed a little bit. After starting to work on it, I found that it was easier actually to mount the third one way over here and just run a negative jumper wire to it. The other two are here, and then the safety cap, there was a large fat cap there, rated at 1/10 of a microfarad, and it was taking up the space where I wanted these to go, so I took that out. So now we're going to see if there's going to be smoke, or will there be radio edge. Let's see, do we have filament? Yes, I see filament. And since the grounding cap is so much smaller, it might interfere with reception a little bit, but we'll see.
Dillard on your home for 24 24/7 News, the Black Information. Save up to 1,000. Reminder. Life let.
It's surprising. It's actually really sensitive. It's picking up like stations just barely breathing on the dial. Maybe I was too mean to this set. Maybe it's not so bad. No, maybe I shouldn't be so hard on 4 tube wonders like this. So we've got 2 more capacitors to replace, and then I want to clean the volume control. You see it's got these little slots. That's where the wipers exist inside. We need to clean those up. And then we'll clean up the top side and lubricate the tuning mechanism. And then I'll start working on cleaning up and polishing the case, which is, I believe, looks to me made out of Bakelite. You got to be careful with Bakelite. You don't want to scrub this stuff, or you don't want to use harsh cleaners, or you'll ruin the surface, and it'll be dull forever if you do that. So let me replace these last 2 capacitors, and then I'll need to do a safety check to make sure that it's going to be below our current 2 chassis threshold that we've set up for ourselves at our organization. We kind of have to do that because we're a nonprofit. We have to make sure that everything we send out is safe. Now, if it's for me, I don't care. Like, I'm not going to be stupid and stick my hands inside and touch it. And this one's got a very good back, so it'd be very difficult to do that anyway. So the threat of, even if I didn't have the safety cap, is pretty low. Okay, so the remainder of the capacitors have been replaced. So now it's time to clean out the volume pot and work that in. Okay, let's test it to make sure we're still working. I suspect it probably will, since there's exactly 10 parts inside. And let's see. Yep, we got the filament. And I tell everybody that is not familiar with these when they come to our shows, like, they don't turn on immediately. You got to wait about 30 seconds or so. Not even that, maybe like 15, 20 seconds at most. Interesting. So now I've got static across the entire band. So I'm wondering if one of my tubes has worked itself loose. Alright, let me see what's going on up here. Oh yeah, that to clean the tube sockets.
So they're very attracted to that. But our Lord tells us, He exhorts us.
Will you help us this Passover season?
Toronto's pushing the ball. We can come. In the first hour, traffic is backed up to the Bay Bridge Tower as a result. Taking a look at your Bay Area weather, gonna be clear over value right now and jumping on it.
2% of their traffic.
It's a very clean sounding radio. Now, it's got some static, but again, I need to clean these tube sockets. And I want to oil this bearing and all these other surfaces for smoother, cleaner sounding operation. I think to get to the tubes and clean their sockets, I'm going to take this back off. Let's see. Looks like we're just soldered here. It might be worth desoldering that temporarily so it doesn't tug on that ferrite rod. These are very fragile. You can break them just looking at them. Okay, so I cleaned the chassis, the tubes, and their sockets. It seems to me that this was kept somewhere clean and dry. It's very clean. Most of the time I get these in, they're kind of corroded. So we're going to oil the bearings with some Zoom spout oil, including a twisty-turny part, because it'll just make it turn a lot nicer. That already feels a lot nicer. It's all about that tactile sensation. Likewise, I'm going to do the volume pot shaft. Get a little oil on it. And work that in a little bit. Oftentimes it'll work in with a little bit of capillary action. You don't want to get any oil on the tuning string. You'll be sorry. Trust me. So now that it's all cleaned up and everything, let me give it another test just to make sure it's working, and then it'll be time to add the oh so popular infamous audio input feature, which I add to most of these little dinky sets because, let's face it, there ain't much listened to on AM in many places anymore. In fact, I believe in Europe they've canceled actual radio broadcast entirely. I can't remember which country it is. It's like Norway or Denmark, or one of those countries over there, and they no longer have AM or FM broadcasts, which is kind of interesting. All right, we're still working on all cylinders.
Your words with paper.
This is a Daewoo cologne for the Black Information Network.
Brad found a great home with a yard.
And that way we overcome that fear.
It's so sensitive, I'm not even going to bother with trying to do a alignment. It's perfect. Now, what I need to do before I add the oh so famous audio input is make sure it's going to pass safety. There is two things going to ground on this one. There's a resistor and then the safety cap I've installed. That doesn't guarantee that it'll pass, so let's take it over to our safety rig and see what happens. Okay, so here's our safety rig. On the 2 volt AC setting on my multimeter here, the maximum that we want to see as far as represented current will max out at 0.6 of a volt, which is low. That's real low. In fact, I think it's ridiculously low. So 0.06, and then we need to reverse the polarity to make sure that we're on the hot side when we're testing. 003. That's clearly the neutral side. That's very low. This is passing with flying colors. All right, so we've essentially completed the bulk of the electronic restoration as far as making it a whole radio again. So now we're going to add the audio input feature that I know so many of you like so much. All right, so I've gotten all the components ready for the audio input. First, we have the 3.5 millimeter stereo cable running through this rubber grommet with a knot tied in it. And that will go through this, which is what we're treating as an isolation transformer. It's not magic. All it is it's 110 volt winding for the primary, which is this side, and then 6 volts out. For the secondary, we run primary side towards the volume pot. And this is pretty easy to demonstrate. We have a top and a bottom leg off of the volume control. The top goes to this IF can. That's the radio signal coming in through here. And this basically is a giant resistor. It's going to reduce or increase that signal potential, hence your volume. The other side is the bottom of the pot, which goes to ground, which is going through to our common ground connection here, which goes through the safety cap to ground. So what we want to do is run the audio through here and there. Our negative here, our positive there. We're going to have a little wire that temporarily connects this line to the volume pot so that we can temporarily disable that radio signal, so that if someone wants to listen to their audio, they don't have to worry about AM interrupting. And got to do more than that than just running it through there. We're going to need to make sure and run our right and left channels together through a pair of 33 ohm resistors. Here we have right and left on either one of these two legs here. And then this is tied together. It'll mix the signals together for true mono. And then on the primary side, which is again this side, we want to make sure and have, this is a, it doesn't really matter the value that much, 0.05 rated cap and a 270K resistor. And what that's going to do is make sure that when the transformer is connected to the volume pot, that it won't interrupt the set's automatic gain control. Because we had some problems earlier, especially with some of these dinky little sets where the transformer would cause the radio signal to oscillate and squeal. And so putting that in kind of provides a little bit of a back shunt, so that won't happen. We're going to glue it here with some super glue. I've roughened it up and cleaned it with rubbing alcohol. And I roughened the back of the transformer. And so I'm going to go ahead and install that, and I will show you what that looks like on the other side. Okay, so we have the isolation transformer hooked up, and that's going through the resistor and the cap to the top of the volume control, and then we have a switch wire temporarily disconnecting the IF signal. And we'll have to shorten this. You want to keep this as short as possible. But now I've got a Bluetooth running through. The radio should be disconnected. That's what I want. Good clean audio, and then when we reconnect the when we install this little, where'd that middle micro switch go? Uh-oh. I've lost it. I hope I didn't. Where the hell did it go? Oh, there it is. Okay, what we need to do is attach this little switch through the back of the back cover so that we can turn the radio signal off and on. And then we should be good to go. So this, sometimes I love these simple little radios. They take so little time to do. All right, so we got the switch installed in the back. This is done. The last thing is going to be to clean up the case. I've learned recently it's much easier to use power tools to do it, so I'm going to use my car wax, and we're going to buff up that case. All right, so she's done. I got it all shined up. That didn't take near as long because I had the tool. Sometimes I feel like that's cheating, but my hands would get all cramped up from after polishing these by hand. But now I've got the Bluetooth running through it. You're not going to absolutely rock the neighborhood with this thing. I mean, but that's probably not why people get these anyway. It's not like you're going to sit there and be, boy, man, that's an awesome sounding sound system. But you know what? Even little dippy radios need some little love. And so this one is basically got a new lease on life. It's in very good cosmetic condition and electronic condition as well. And so that concludes this episode of Radiorama. I'll probably turn it back on to let it run for a few more hours. I want to make sure nothing's going to break down thermally. But anyway, I'll see you guys next time. I'm not sure what I'm going to work on next. There's quite a few of these little plastic radios that have come in recently, and they are very similar in construction. So I'm like, what other interesting things should I work on besides this? But I know we need tons of these things ready for our next show. See you guys next time. Adios.